Hello everyone, I'm Muhammad Nasir. Currently I'm pursuing BTech second year in CSM department at Srinivasa Ramanujam Institute of Technology. So today our topic is state and prove Euler's formula for planar graph. So Euler's path. A path in a graph G is called Euler path if it includes every edge exactly once. That is, since the path contains every edge exactly once, it is known as Euler's path. Euler circuit. Euler circuit is a Euler's path which starts and ends at same vertex. Euler graph. A graph is called a Eulerian graph or Euler graph if it contains Euler circuit. State and prove Euler's formula for planar graph. Planar graph. The Euler formula is for planar graph states is V minus E plus F equal to 2, where V is the number of vertices and E stands for number of edges and F stands for number of faces, including the outer infinite faces. The formula applies to connected planar graph. Planar graph, a graph that can be drawn in a plane without edges crossing. Let's go through a proof by induction on the number of edges E. So proof of Euler's formula. Base case is consider a planar graph with V equal to 1 vertex and E equal to 0 edges. Since there are no edges, there is only one face, the outer one. Here V minus E plus F equal to, that is 1 minus 0 plus 1. So here we applies VEF. So here the vertex is 1 and the edges, there are no edges, so that is equal to 0, and there are only one face, that is 1. So 1 minus 0 plus 1 equal to 2. So the formula holds in this case. The inductive step. Assume the formula, that is V minus E plus F equal to 2, holds for any connected planar graph with E equal to k edges. We want to show that it also holds for a planar graph with E equal to k plus 1 edges. So here the inductive step is we want to show that it also holds, that is E also holds for a graph with E equal to k plus 1 edges. So inductive step. Case 1. Adding an edge that does not create a cycle, that is a tree edge. So we have to add an edge. That edge does not create a cycle. Okay. When we add an edge that does not create a cycle, it connects two previously separate components. So we gain one vertex or one face, but keep the edge count as E equal to k plus 1. Here, when we add an edge that does not create a cycle. So when we are adding an edge that does not create a cycle, that the cycle means loop. Okay, it connects two previously separate components. It connects two previously separated components so that we can gain one vertex or one face, but keep the edge count as E equal to k plus 1. The result satisfied the formula. So because adding an edge or a vertex without creating a cycle does not describe the equality. So here we have proved that the main theme of this planar graph is we should not create a cycle while adding an edge. So here while we are adding an edge that does not create a cycle, it connects two previously connected. So here we are proved that the Euler's formula, Euler's planar graph. So to prove that the main theme of Euler's planar graph is it does not create a cycle. So here while adding an edge, it does not create an cycle. So this results as formula this result satisfy the formula because adding an edge or a vertex without creating a cycle does not disrupt the equality. So here we have proved that the Euler's planar graph. So thank you.